is Epsilon Pi Epsilon, and I'm the director of UP Make. If you don't know what UP Make is, it's one of the programs that UP has, where we focus on hardware development, 3D printing, and 3D modeling. Um, so for the upcoming workshops that we have one more workshop that's going to be part of the cohort program events. So if you want to be able to participate in some of these cool workshops that only the cohort members have access to, then make sure to apply next year. It's pretty cool stuff that we've done. So like one of the projects that we had, or one of the workshops that we had, was creating an autonomous robot with an Arduino. And then the one that we have next is the ping pong workshop, where we're going to be able to create a ping pong game and have it communicate with specific components. So we're going to be using potentiometers, and then we're going to be using the Raspberry Pi to have the game display on our screen while we move the potentiometer. So we're going to be able to move the actual paddles within the ping pong game, which is pretty cool to do with the Raspberry Pi. But yeah, so tomorrow I believe is the last day to my. Okay. This Friday is the last day to apply to the EBoard. So if you want to get involved, if you want to become a part of the EBoard, there's a lot of positions open. Even mine, I'm graduating next semester. So if you're interested in my position or any of the other positions, make sure to reach out to me or any of the other EBoard, and then we could help you out with that if you have any questions. Most likely a lot of you already are in the Discord, but if you're not, make sure to join. That's where we put all the stuff that we're doing within UPE. And we want to start to have it be more of a place where we could chill out. So since we don't have the space, we're all virtual. We're gonna, I don't know if you've been seeing it, but we're always in the voice chats and we're just there chilling. And if you have any questions or you just want to talk, we'll be there. Social media, if you want to maybe post that you're here at the workshop, or whenever you do some of the demos that we do for Make or Code, you could always post that on your social media and tag UPE, and we'll make sure to repost that for you. So for today, we have the Raspberry Pi Workshop. I am sure you've noticed that my webcam is a little bit different. The reason for that is because since we're going to be using the Raspberry Pi, we're going to have to connect the Raspberry Pi to the monitor. So starting off for the beginning of it, I'm gonna have it like this so you guys get a sense of how to configure your Raspberry Pi. And then once we get the VNC connected, then we won't need this camera view anymore, since we're gonna be able to access the Raspberry Pi from our computer instead of having it connected to a monitor. But yeah, so first of all, what is a Raspberry Pi? A Raspberry Pi is a very small card-sized computer that, like any computer, has a CPU, has RAM, and has different peripherals that we could attach to it. So some of the choices of RAM that you could get, depending on which one you want, you could get 2 gigabytes, 4 gigabytes, or 8 gigabytes. We have the processor. This is the Raspberry 4. So it's the newest one that has come out. As you can see, the HDMI ports are micro HDMI. They're not the usual ones that we see. But that allows us to have it support 4K displays if for whatever reason we wanted to connect it to that. So why use it? Why would you want to use a Raspberry Pi? For one, it's very portable. It's really small. So for multitude of projects that you might want to do, it will be the ideal thing for you to use. I'll give you an example for my senior project right now. So a little bit of insight. I'm a computer engineer. So we have to actually create a product. So our product is using the Raspberry Pi to connect it to a car so that we could access the information of the car and display it to the user. So maybe if you get a check engine light, or if you want to know the location of your car, we're going to be using Raspberry Pi with a few other components to do that, to have access to that information about the car so that it makes the life of the user or the driver a lot easier when it comes to like your check engine light and maybe where you parked your car. I don't know about you guys, but multiple times has it happened to me where I've gone to campus and I've forgotten where I parked my car. I'm not happy about it, but hopefully this is something that will fix that. Anyways, it's also very powerful. It has a quad-core processor. Like I said, you could get the older ones have 1 gigabyte of RAM. The newer ones have 2, 4, 8 gigabytes of RAM. The community is huge. So what that means is that you're going to have a lot of libraries that you could access for a multitude of things that you may want to do with your Raspberry Pi. Not only that, you also have a lot of GPIO pins that you could connect different components to your Raspberry Pi. And a lot of these pins use different functions, or you could just use it as a general input or output pin. You could also connect the screen to it or a camera. As you can see here, this little slot here is for a camera. Something that some people do with the Raspberry Pi is that they use Octopi with the Raspberry Pi so that they can create time lapses of 3D prints. And that's really cool because it allows you to make a 3D print look as if it's creating itself out of nothing, which I don't know if you've seen those videos, but they're pretty cool. And then they also are very easy to use compared to industry microcontrollers or microcomputers. So that's a little bit about the Raspberry Pi. To talk to you a little about the GPIO pins, which is one of the main functions or features that Raspberry Pi gives you. We have voltage 5 volt or 3 volts as well, 3.3 volts. If you did get the hardware that I had given you guys for the requirements, then if you have 5 LEDs lights, then you could use the 5 volts because the Raspberry Pi 5 volt GPIO pin allows you to get 200 to 300 milliamps. But any single LED within a LED strip takes 60 milliamps. So you do the calculations, you'll be able to get 5 LEDs to turn on if you were just to use a Raspberry Pi. That's why if you want to use more Raspberry Pis, you have to buy a power supply, which I also provided for you guys if you guys were interested. Now you also have your ground pins. You also have different communication pins. So SDA and SCL are I2C protocol pins. What that means is it allows you basically to communicate with different sensors through serial communication. Similarly, you also have SPI, which is similar to I2C, but it does have a little bit of a holdback because you do have to connect more wires if you want to connect more devices to it. You also have TXD and RXD, which also allows you to communicate. But this is not so much of a protocol as these. These are actual circuits that you have within the board that allow you to communicate. Something else to mention is that we have 4 PWM pins. The one that we're going to be using is going to be GPIO 18 for the specific demo of controlling the LEDs. But we'll get to that later on. So what we'll be learning today, we're going to learn how to set up the Pi. We're going to learn how to SSH and remote into the Pi. We're going to learn how to use the terminal, download some libraries. We could also update the OS. We're not going to do that because it takes too much time, but I'll show you guys how it can be done if you guys are interested. And it's something that's highly recommended whenever you are programming on your Raspberry Pi, just so you have everything up to date. And then lastly, we'll learn how to connect to a Raspberry or to an LED strip to the Raspberry Pi, and then program it with Python. So hopefully you guys did it. If not, it's okay. But if this is also for the people that may be watching the video, you're going to have to format your SD card, and then you're going to download Noobs, which is the software that we're going to use to then download the actual OS for the Raspberry Pi, which is Raspberry Pi OS. That's the name of it. Also, something to mention that I've faced with is whenever you do have your SD card into your Raspberry Pi and you have your OS already downloaded, if you ever want to format your SD card again, you're going to see that it's already in different partitions. The OS does that automatically, and that could be a little bit difficult to format if you ever do want to format it. So I added this link to a solution for that, and I'll provide you guys this PowerPoint after if you guys are interested. So let's get the things connected. If you're following along, I'm going to disconnect my earphones now. So if you guys have something to say, just maybe show me in the camera. But go ahead and connect your SD card, your keyboard, and your mouse to the Raspberry Pi. And then we're going to connect it to the monitor. And then let's connect this. All right, so now we have connected. Just go ahead and turn on your Raspberry Pi. switch to the HDMI that you're connected to. Let me put this a little bit more up. So something to mention is that if you do have your Raspberry Pi, you could use multiple different power supplies. The recommended is always 3.0 amps for the Raspberry Pi 4 and 2.5 for the 3. But you could use any phone charger. If you have an iPhone charger, that'll be better because it has more amps. It's usable but not recommended. It depends on how many components you're using and how much current you're taking. So hopefully, if you did download your OS already and you have it installed on your Raspberry Pi, then we should be good. If not, then you could always just reference this workshop. But at this point, what I want you guys to do is just connect to the Wi-Fi. So you do that just by clicking up here on the the wireless LAN icon and clicking on the Wi-Fi that you have at your house. If it doesn't let you, then that might be because some of the configurations that you missed out on. You have to make sure that you let the Raspberry know what state you're in, so that I assume because of some protocol that maybe is specific to the wireless connection. So yeah, you would set your WLAN country, and then you'll be able to, if for whatever reason that's not working. Okay, so let's go ahead and practice a little bit with the terminal. What I'm gonna do right now, though, just so it's easier for you guys to see, is that I'm going to connect to my Raspberry Pi through my VNC already. I'm still gonna go show you guys how to do this, but just so that it's easier for you guys to see the screen, I'm gonna do it like that. So where are we? Yeah, the terminal. So let me put this here so you guys could also see this. Sorry. So for the terminal, you have a few commands that you have access to. You have sudo, you have cd, you have ls, you have pwd, and you have mkdir. What these commands allow you to do, first of all, the sudo gives you privileges. So think of it as admin privileges. And with Linux-based and Unix-like operating system, these are all the commands that are similar. If you have a Windows computer, you could use PowerShell if you want to use these same commands. But so let's practice a little bit. Right now we're in the root directory. So if we do ls, we'll see the list of computer files within that root. So you see the documents, you see downloads, music, whatever. Now let's say we want to go into the documents. So you would do cd and then you would type out documents. You could hit tab, but make sure that it is, or you are using the correct case sensitive letters, because Unix is like that. Let's check what's in there. We have 2 Python files. Okay, well, what if we want to create a folder? So we would do mkdir to make a directory, and then we'll name it whatever we want it to be. In this case, I'll just name it folder. Let's check if it made it, and yeah, it's there. Now, what if we wanted to delete it? Well, if you want to delete it, then you would use the rm command. If it's empty, then you could just do -d and then the name of the folder. If it wasn't empty, then you would have to do -r so that it's recursively deleting all the files that's within that folder. And you can see it deleted it. You also have pwd, which will give you the path. And sudo, like I said, it gives you privileges for specific programs or methods that you're trying to run. In this case, we're going to be running sudo raspberry config. Let me know if it's easy to see. Maybe I could increase the font if it's too blurry or something. But what this is going to do is going to give us access to the configuration tool so that we can go ahead and change. So let me do that again so you guys see. Go to interface options, interfacing options, and we're going to enable VNC. So VNC is what allows us to use this right here that I'm doing. And then I'm also I'm going to show you how to use SSH. So SSH allows you to connect to your Raspberry Pi, but connect to it through your terminal. So instead of having this display of your actual computer, you would only be accessing it through your terminal. So first, I'm going to go ahead and do that. I wouldn't say you have to do the SSH because I'm going to be just showing you. We're not going to be using it. We are going to be using the VNC. But the reason that I would say not to use it right now is because having that SSH open can be a security risk if you don't know what you're doing. In terms of like people that are maybe trying to hack you or whatever. But yeah, so now that we have that connected or that on, then something that I would tell you guys to download. First of all, go ahead and download VNC Viewer. I'm going to go ahead and post this link in the chat so that you guys could download it if you guys are following along. VNC Viewer is what we're going to be able to, or what we're going to use to remotely connect to that and have that screen there. I would also say if you are interested in using SSH, then you could download PuTTY. I'll show you how PuTTY works. I have it downloaded. So PuTTY is this tool right here, and then it's asking me for a host name or an IP address. So if you go back to the Raspberry Pi and we want to find out what the IP address is, then all we have to type in is ifconfig, and it'll give us a whole bunch of information about our IP and packets and all that type of stuff. For me, the IP of my Raspberry Pi is this right here. You guys will all have different IP addresses. So you would use that to connect from your computer. So now that I have that IP, I'll bring up PuTTY and I'll put that IP in there. The port is 22, and we are SSHing into it. So now that we're connected, it's asking me for the user, which is Pi, and then for my password. Now by default, it's going to always be RaspberryPi, or no, sorry, not Raspberry Pi. It's just going to be Raspberry. I would recommend that if you are using SSH, make sure to change your password, because since it's the default, anybody will know what your password is. But now, if I do ls, we'll see that all my files are there, and I could cd into anything that I want, as if I were connected to the Raspberry Pi through a monitor and a keyboard and all that. So this is essentially making it a lot easier for you to program and connect to your Raspberry Pi. So now that I showed you that, that's it. And then for the VNC is the same thing. Since you enabled it in your Raspberry Pi, you would just have to put in your IP in there, and it will give you an option to put in the password if you do have a password, and then you'll log in like I have it here. Perfect. So at this point, I'm going to go ahead and disconnect my keyboard and my mouse and also my monitor, just so that I don't have to have these things on my table, and so that there won't be any issues with the current whenever I'm using the LED. It's not that big of a deal, but it's more for the cleanness, I guess. Something else to mention is that since right now, for example, I don't have an HDMI connected, your Raspberry Pi is going to ask you to have a default resolution. So for that, if you exited this page, just go ahead and do sudo RaspberryPi config again, or RaspberryPi, and then we're going to go to advanced options, resources, and we're going to change what the resource is by default, because if we don't, then it's always going to go to whatever the monitor is. But since whenever we turn on the Raspberry Pi, it's not going to have a monitor connected to it, it's not going to show you a display, if that makes any sense. Hopefully I explained that well. You could put anything. In my case, I'm just going to put 1280 by 720, 16 by 9. And there we go. So it's going to ask me to reboot. I'll go ahead and reboot just so that you guys who are following are doing that along with me. Okay. So after this, we'll give it a second. At this point, now that hopefully you guys use your VCN or VNC, sorry, to log into your Raspberry Pi, you could do the same. Disconnect your controller, or not your controller, but your keyboard and your mouse. And now while we wait, I'm going to talk to you a little bit about I2C and SPI. So I mentioned this in the beginning. These are pins that are also on the Raspberry Pi that allow you to communicate to different devices bit by bit. Now for the actual demo that we're going to be doing today with the LED strip, you could do the same. You could use these protocols for For our demo specifically, we're going to be using the PWM pin instead of using these protocols. But if you are interested in this, this is also a more secure way of communicating, since the PWM pins can be sometimes a little bit unreliable on the Raspberry Pi. But yeah, so the I2C is a protocol that uses serial communication, so you can connect two different devices synchronously using the same bus. And as you add more devices, you're not going to have to add more wires. But with the SPI, you do have to add more wires, which is the inconvenience of it. But similarly, it's a communication that you're using to contact and send data to embedded systems and devices like that. Okay, so let's see if my VNC is open again, or my Raspberry Pi is logged in. So then I'm going to put my password. And then it says that I have SSH enabled, which is not something that I should do if I'm still logged in with the same default password, since I'm giving access to my network if someone knew how to access that. So I'm going to just go ahead, before I continue, turn that off. Oh, wrong one. Turn that off. Okay. So now we're going to go ahead and download we're going to upgrade upgrade Python. So by default, with the OS that you get from Raspbian, or from the Raspberry people, you're going to have Raspberry Pi 2 and Raspberry Pi 3. Raspberry Pi 2 has been deprecated. It's not really used anymore unless you're using it specifically for some applications. So in this case, we're going to be using Python 3, but we're going to update it. So go ahead and use these commands that you see here. I'll type them as well. If the first one doesn't work, because sometimes it doesn't work for specific people, or like depending on the operating system that you got or when you got it, if that doesn't work, then just go ahead and type that second command here that you see right here. Let's see if it worked for me. I'm going to go ahead and move this camera so it's facing me, since there's no need for it to face that anymore. Okay, so it looked like it downloaded, but in the case where it doesn't download for you, I'll do that second command as well so that you follow along. Soon enough, we'll get to the actual programming of Python, so don't worry about that if you're anxious. I wrote it wrong, 2 P's. Make sure you write it right, or write it correctly. All right, perfect. So now that we have upgraded Python, we're going to go ahead and download the libraries that we're going to be using. So go ahead and do sudo pip3. Pip3 is the installer that allows us to download these libraries from the internet. Now, this first library, RPI WS281X, what it is a library that allows us to control the LEDs on the LED strip. Now we could do that with different methods of communication. So in this case, we're going to be using PWM, but you could also use, like I said, SPI or PCM. And then the other library that we're downloading, I wrote that wrong. The other library that we're using, it's NeoPixel, which is a driver. It's allowing us to look at the strip as a sequence of LEDs, and then from that as well, having us store those colors in tuples. Tuples are rows. So then essentially we're having rows of RGB colors. So R, which is one number, G, which is the other number, and then B, which is the blue number. And you'll see what I mean once we get into the programming. But now that we have that downloaded, I'm going to go ahead and talk to you a little bit about PWM, and then we'll start programming. after we connect the LED strip. So what is PWM? PWM is a technique that allows us to take analog-like signals out of digital pins. So the pins that we have on the Raspberry Pi and the ones that we're using will allow us to give these PWM signals to the LED strip, and then the LED strip will take that information and make different colors and different sequences and stuff like that. Essentially, the way that PWM works is that the length in which the current or the energy is on will determine what PWM you're trying to write. So if you have a 50% duty cycle in which you have your signal on and off, then you're going to get 127, which is half of 255, which is the max that you could get. And yeah, that's PWM basically. Now let's go ahead and connect the Pi and the LED strip and the power supply. I do realize now that maybe it should have been better for me to leave it up. So I'll put it back up while we connect this, just so that we could get that part out of the way. So if you have the power supply that I provided for you guys, then you guys should have a LED strip that is 60 LEDs. What you're going to do is you're going to cut 10 of those off so that you have 50. Reason being is our power supply that we bought, or that we got for this specific demo, is 3 amps. So 3 amps will be enough specifically for 50 LEDs. So that's why we're doing that. Now, if you have maybe just a smaller LED strip of 4 LEDs, then all you have to do is connect that directly to the Raspberry Pi. You don't have to use any power supply. And then we'll see how to connect that to the Pi now. But go ahead and get your power supply connected to your outlet. And then get your LED strip. You're gonna get the data in, which is the green one, and you're gonna connect it to the pin that's 6 from the top right. So I'll show you a diagram so you guys could get or see what I mean. 4, 5, 6, and then also the ground is gonna go right next to that. So let me enlarge this for you. So you're gonna get the ground. So if you look at this, you have the part that connects to the charger, and then you have the part that connects to the Raspberry Pi. Connect ground to ground on your Pi, which in this case would be the 3rd one. And then the data in, which is the middle one, to the 6th pin on the right. And that's going to be our PWM pin. And then we'll just go ahead and connect the power, and then we should be good. This should be good to go. All right. So now if you have less than 5 LEDs that you're using, or if you have 5 LEDs, then you'll be able to just connect it directly to that, to Raspberry Pi, and the Raspberry Pi will use the 300 milliamps that it has from that pin specifically to power this LED strip. Okay. Yeah, so be sent on the Discord. Okay, so now that you guys have that connected, hopefully, we're going to go ahead and review some Python programming before we start working on actual Python, in case there's any beginners, or you get a sense of how Python works and how programming works in general. So starting off, Python is let me put this big. Python is a loosely weakly typed programming language. What that means is that for any variable that you assign a specific character or number or whatever it may be, that variable can change throughout the program. If you compare it to Java, for example, whenever you initialize a variable to something like an integer, you can't really change it to a variable. That specific variable has to stay the same. And then the same thing with Python. Similarly, like, you don't have to specify what data type you're using. Python will assume that it knows, and it will create that variable from what it assumes that it is. So in this case, it will know that this is an integer, this is a Boolean, this is a string. If for whatever reason that it doesn't recognize that, then you could always explicitly say what it is. So in this case, you would use int parentheses 5. You also have if and else statements. It's a little bit different in terms of the syntax. For the else if, it uses elif. And if you don't know what an if and else statement is, basically the condition, if it's true, then it will execute this statement. If it's not true, then it'll go to the next one. And since we have an else if here, it'll check the condition again. And the last else is basically the default in case the other two conditions are false. We also have for loops, where the first variable is the variable that we're using to access whatever it is in that sequence or list. So this is an example right here where we have an array of numbers or integers, and we're using val to get access to those and printing them out in that sequence. After that, we also have functions, which are basically blocks of code where we use the keyword def to define it as such with the name of that specific function. And we could also include arguments. So in this example, we have a method that is taking the sum of two integers. And we're passing those two integers with a and b. And then we're returning it back to wherever this function was called. Two other things to mention is we have bitwise operation and floor division. These are operations that you can use within Python. With the bitwise operation, basically you're taking the binary of a number, and then you're multiplying it by another number, and then you're getting the binary of that. And I'll explain to you that later on once we start programming. The reason that I bring this up is because the program that we're going to be using or writing does have this. Okay, so let's start programming. We're going to start off simple, and then we're going to get a little bit more difficult so that we could get a sense of how these methods that we're getting from the libraries that we downloaded and how Python works in general. So I'm going to put this on the side so that we could reference it. And let's go back to Python. So from here, what we're going to do is we're going to go to program. We're going to click on this home programming and then go to Tawny Python IDE. This is what we're going to be using to actually write the programs that we have here. We're going to click on new. You might not need to since it should be blank. So initially we're going to import board. That's going to allow us to recognize the actual pin that we have and the pin that we're using on this board. And then we import NeoPixel, which is one of the libraries that we downloaded. And that's going to allow us to have access to those methods like fill and show, which will basically, how it says here, fill will make all the pixels the given color that you make it, and show will, if you in the constructor of the class, when you're initializing that object, if you make it auto-write equal to false, then it's not automatically going to change to the colors that you put it when you first call it. So this is what I mean. We'll see with this example, but basically, yeah. And we have different arguments, so we could also change the brightness. We could change the pixel order. So what that means is that sometimes the LEDs that we buy will come in GRB instead of RGB. So in that case, we would use this pixel order so that we could change that. And then the PPP or BPP is the bytes per pixel. That's the same thing with the RGB. If you have RGB, then it's 3. If you have RGBW, which is red, blue, green, or red, green, blue, white, then it'll be 4. You have the pin, which is a specific pin that we're using, which is going to be 18 in this case, and the number of LEDs that we're going to be connecting. Okay, so now that I gave you a little bit of insight so that we know what we're writing, we're going to create this object of that class type so that we could have access to those methods and everything else. So we're going to specify the actual pin using that board import that we called. And then that pin is going to be 18. And then the number of LEDs that I'm using is 50. If you have more or less, then you would change that to whatever it is that you're using. So then if we wanted to access the first LED strip or the LED within the LED strip, then we would call it by an array. And that's what I mean when we say that NeoPixel allows us to look at the LED strip in the sequence. And then we tell it what color that we want it to be. In this case, we're going to make it red since it's RGB. Red is 255 and the other two are 0. So let's save that. We'll call it whatever. We'll say first example and then click OK. Now you can't run it here because since we're using the NeoPixel library, we're required to use sudo so that we could give it those privileges that it needs. From this point on, we're gonna go ahead and go to where that file is located. So we'll do ls. We know that it downloaded to the documents, right? So then we're gonna cd into the documents. We're gonna check if it's in there, and it is in there. First example. So to run that, we're gonna call sudo, and then we're using Python 3. Remember, right? So then we're gonna use Python 3. If we don't specify that 3, then sometimes it could use Python 2, and then obviously we don't want that since they're different languages in a sense. And let's see. And as you can see on my LED strip, the first LED is on. Wow. Wow. Yeah. So that's pretty cool, I guess. So now what if we want to use that pixels fill method that NeoPixel gives us? We'll be able to call it. Remember to put 2 parentheses, because for whatever reason, I think that they have you, yeah. So they allow you to pass 2 different parameters of a sequence of numbers. So that's why we want the 2 parentheses, but in this case, we're gonna make it blue, but we're gonna make all the colors blue on the LED strip. So let's save that. Go back to the terminal. If you want to always call the same method or the same command that you just entered, you could always press up on your arrow key and it will bring that back. And we have green. Pretty cool. Okay, so now that we have that, let's see if we could maybe create an animation out of this, right? Because what's so cool about a LED strip if you can make it do different sequence of lights? To fine tune the LED colors. Yeah, so I don't know a specific website, but I'm pretty sure that there are many websites that allow you to do that. Miguel, maybe you could look one up. But I know that there's ways for you to pick a color and they'll tell you what hex or what RGB color or like numbers to use. Yeah. Miguel will find that for you. But now, if we want to create a sequence in where the LEDs turn on sequentially or like in the sequence, then we'll use the range or the for loop where we have the range go from 0 to 9. And then within that for loop, we're going to access each pixel and change the color of it in that order from 0 to 9. And we're going to make them all green, but they're going to change to green, or I mean RGB, to red in the order. And then we're also going to call sleep. And the reason that we call sleep is because if we don't, then the program will run it so fast that we won't see that iteration of the LED lights turning on. And I forgot to import this, but we need to import time. Because if we want to call this sleep method, sleep is a method that comes from the time library, where what it essentially is doing is it's breaking or stopping the execution of a thread, of this thread specifically. So let's save that. So since we have all this together, it should go in sequence. So it's going to turn on the first one, then they're all going to be blue, and then they're going to go in that sequence. Let's see what happens. And it's doing it. One LED at a time. Wow. Cool. So I'll leave that to go through all the LEDs, and then we'll go on to the second example. So now we have a sense of how fill works. I don't think we use show, but we'll use show on the next example. But we have an understanding of how these LEDs are turning on. Now, what if we wanted to create a show or an animation out of this, right? So we're going to use that show method, and we're going to make that auto write equal to false. so that whenever we are initializing these LEDs to this specific color, until this show method is called, they're not going to turn that color. And then that way we could create that sort of animation where it's going from R to G to B in a loop within this while loop. So let's go ahead and program that. And what happened to my Raspberry Pi? It might have gotten disconnected. Let me try to connect to it again. Let me disconnect the LED strip just in case. And you can see that even when I disconnected the LED strip from the Raspberry Pi, the colors that I had them at stayed at that. Let me see if this connects. If not, then I'll just restart it really quick. Yeah. Okay. But yeah, so don't rank me, but I created this makeshift nanoleaf DIY, I guess you could say. I was gonna do it with my 3D printer, but sadly my 3D printer broke. I have to order a new probe. But essentially, this is the idea behind what you were gonna be able to do with this. You would create your own nanoleaf. If you don't know what a nanoleaf is, then you can look it up on the internet. And take the 3M tape behind the LED and put it within the nanoleaf. Let's see if it's up now. And it would look pretty cool. It would definitely look cooler if it was 3D printed, but hey, you gotta use what you got, I guess. Okay. And it turns off. That's fine. Looks like we're back up though. So let's go ahead and finish up this second program. So again, we're going to go to programming, Thonny Python IDE, and then we're going to create a new file. We're going to import time since we're going to be using that sleep method. We're going to import board so that we know what pin we're using. NeoPixel. Let me see if I could maybe make this bigger, so you guys can copy off that as well. So something else that we're going to do differently here is that we're going to initialize some of the values that we had within that constructor of the NeoPixel class, so that it's a lot more readable for us. The number of pixels, I'm using 50, depends what you're using. And then the order. So we're going to be changing the order because the NeoPixel that I got, or the LED strip that I got, did come in reverse. So by doing this, we're putting it back to the proper order of RGB. So now let's call that NeoPixel class and create that object. So the pin is going to be pixel pin. The number is num pixels. Brightness, we're going to lower that to 0.2. And then auto write, we're going to make it false. And again, the reason we make it false is so that we could use that show method later on, so that we can have them all be turned on in the proper sequence that we want it to be. And then the order. Yeah, so I could explain those, the variables. So this pixel pin is basically how we were doing in the other example. This is making it known that the board pin that we're using is pixel pin, so that when we create that object using that NeoPixel class, it requires this argument of what pin we're using. Similarly, the number of pixels or number of LEDs that we're using, the order, we're making it GRB instead of RGB because our LED strip came reversed. So if we want to reverse it back to the proper way it is, which is RGB, we have to make or let the program know within this argument that we're using this order of pixels. And I think that's all the variables. Yeah, we also have brightness, but yeah, brightness is pretty self-explanatory. And then from here, so let me do that. We're going to make while true, and the reason why we do this is so that it continuously is executing. We could look at this while loop as the main method of this program, where that's where it's being initialized and that's where it's calling all the other parts of the program. Okay, and then we're going to do pixel.show so that it shows them when we call this method instead of when we initialize it here, so that we could then have a delay of 1 second. Now we could go ahead and just copy and paste it multiple times, and then just change that color so that we could get that animation that we're trying to get. So R, G, and then B. And then this will be 0 and 0. All right, let's save that. And then we're going to say this second example. It's also in the document, so we'll go back to the terminal and navigate to that folder. Okay, and the internal IL. I'm sorry, I don't know what intentional IL means. It's IL. So now let's run and see what happens. Python 3, second example, and let's look at our LEDs. Okay, what did I do wrong? Python. GRD. It's GRB, not GRD. Save. Pretty much. Oh, yeah, pretty much. Okay, what now? Fills. It's not fills, it's fill. Always during the real presentation do we get these little issues, but it's fine. Oh, I don't have it connected. I'm a dummy. Okay, so ground goes to the 3rd, and then data in goes to the 6th, or GPIO 18. And we get that sort of a nanoleaf type of effect that we wanted. Pretty cool. Okay, so I hope you guys understood like how that kind of worked, and where we're changing the colors. We're adding that show method, and we're having it be a delay there so that we can see it animate in that way. We have one or more example that we're going to go through. This one is a little bit more complicated, and I don't want to go through the process of writing it out and trying to explain it to you. So what I'm going to do is, I'm going to give you guys a link to this code, so that if you guys are following along, you guys could just add that to your IDE or to a file within Raspberry Pi. And then I'll go through it and I'll try to explain to you what exactly is happening. Oh. But for now, let's leave this as an ornament, kind of. Yeah. Oh, yeah, never mind. I'll just leave it on the side. So let me explain it to you. I have 2 iterations of what this program is doing, because the program, like I said, is a little bit weird. But essentially, what's happening. So same thing. We understand what this is doing. We already did this 2 times already. And we're calling this rainbow cycle here. So this is where the program actually starts, and we're giving it a delay. Because as we can see, there's a wait parameter, an argument within that formula, or within that function, sorry. And we have 2 for loops. So this for loop is first going to iterate through all the pixels, and then it's going to iterate this j through 255. I try to explain this as best as I can so you can get a sense of how this is working and what it's doing. So this is a rainbow cycle. So instead of going through the standard red, blue, green lights within every single LED, it's changing the color of the light in such a way where you're seeing every single color that you could not possibly see, but see in that aspect. So yeah, so for example, when this gets called, we have I and we have J. I is 0, J is 1. We have the pixel index, which is giving us a certain value. So this pixel index, I'm not completely sure how they came up with this algorithm. Whoever created this algorithm is big brain, and you'll see why. But yeah, so you have 0, which is the I. We multiply it by 255, we get 0. Divide that by 50, we get 0. We add 1 because j is 1, we get 1. So now we call wheels pixel index. And we use the bitwise AND operation. And like I said, when we use bitwise AND, we're multiplying the bits to each other. So 1 times 1 is 1, 0 times 1 is 0. And that's basically, that's the way that it works. So then our answer for this is going to be 1. We call wheels 1. Wheels 1 is going to return to us an RGB that then is going to be used to turn on this specific LED light, that color. Now, if we look at the wheel method, we'll see that it's asking where is that value going. So we have 1. 1 is greater than 0, but less than 255. But it's less than 85, so it'll go here. So then if we do these calculations, you'll see that R is going to be 3, since 1 times 3 is 3. 255 minus 3 is 252. And then B blue is 0. So we're going to return these values back to wherever wheels was called, which was to this specific pixel or this specific LED strip. And then we're going to show it, so it's going to turn on. And then we're going to wait a second, or 0.01 seconds. Now, if we were to iterate again and increase these indexes, we'll get 7 once we do this calculation. When we divide this by 50, remember we're flooring it. So whenever you have the number that you're dividing and you're flooring that number, for example, given 7.5 after you do division is going to be 7, the value that you get. In this case, we get 5 plus 2, which is j. So the pixel index is going to be 7. We use the bitwise. We get 7 again. And then as you can see, we still go inside this specific if statement, but we get a value that has a higher red, a lower green, and blue still stays the same. So you're going from green and you're getting more red, you're turning into maybe purple. I don't know how the colors work, but you're going through that rainbow, and it's going to continuously increase the red, lower the green, and eventually it'll start increasing the blue and lower maybe the red. And that's how you're getting that rainbow effect. So now let's try it out. So we'll go here. Is it this one? No. Let me load it up. I don't know if I have it saved on here. Yeah, I think it's final. If not, then I'll just use that link that I sent you guys for myself. Let me quickly log into my Gmail so I could access it, and you'll see what it does. My apologies. Thought I had this part ready, but it's fine. Oh, cool. I'm logged in. Just give me a second, guys. But anyways, I miss actually having programming assignment is what I mean. Yeah, bro. I mean, I practice my programming, but like it's not like being in programming 2 again or being in programming 3 and having all that concept and information in your mind like from the start. But yeah, so let me go ahead and save this code and put it inside here. And let's save this. So you can do the same, and then you'll be able to do that on your LED strip. First, no, not that one. First pi, first.pi. What did I call it? First.pi. And now we get that rainbow effect that we were talking about. Now, if you followed when I was explaining it, then you would kind of understand what I mean when from the first LED, it's a little bit more green, and then the second one, the red is a little bit stronger, and then constantly through those 2 for loops, going through all the number of colors that you could get. And that's basically it. I do have one more example for you guys. I'm not going to explain this because it is way too difficult, but I'll go ahead and post it in the chat as well so that you can try it out yourself. I have it here as well, so I'll show you guys what this this specific program does. It's a whole bunch of different animations that you could create. So first you have the chase. I think they call it the theater chase. But as you can see, I think in the actual program, I only specified that I wanted 30 LEDs, which is why for the other 20, you're not getting any difference in those LEDs. But it has also the rainbow cycle. It has the chase. It has, I think, a rainbow chase as well. So there's a lot of really cool things that you could do with this. And essentially, what you'll be able to do is create a nanoleaf, a DIY nanoleaf. I really wanted to do this nanoleaf with a 3D printer, but like I said, my 3D printer broke, so I need to order a new probe. So I created this cardboard nanoleaf, just so that you could get a sense of how it would look, and you would put this in your background, and it would look pretty dope. But yeah, so finishing up. Nope. Finishing up, I want to thank you guys for coming to the workshop. I hope you guys, I'll look at the camera. I hope you guys enjoyed it. I hope you guys learned something from it, whether that was Python programming or how to use a terminal or setting up your Raspberry Pi. Again, I'm going to share this document with you guys so that you guys can reference it if you want to do this on your own or later on. And if you guys have any questions or anything like that, I'm open to answer. If not, then that should be it.